Hi, it's Jordan again, and I'd like to talk about the experiment that I recently did in terms of creating a fire with a lemon. Yes, I know it sounds crazy, but that is the experiment. And here's the final product of what the lemon ended up looking like once I attached everything. But let me go into more details about the experiment. So I needed, of course, one lemon, 6 copper fasteners, um, 6 zinc nails, metal wire, steel wool, and rubberized wire as well. Hence the yellow things that were attached to the zinc nails and copper pins respectively. And I'll talk more about the procedures. First, I rolled the lemon around in my palms for about a minute or so to get it loosened so that it conducted electricity. Second, I pushed the 6 copper pins into the lemon in a line going long ways rather than the other way because it needs to conduct electricity long ways. And afterwards, I diagonally connected the metal wires to the copper pins and zinc nails respectively. And there were about, let's see, 1, 2, 3, 4, 5 metal, loose metal wires that I used and connected each one to a zinc nail and a copper pin respectively. And for the empty spaces, of course there was 1 copper pin and 1 zinc nail left. So, as instructed, I tied a rubberized wire to one of each, and then I placed the wire ends on the steel wool that had paper towels on top so that it would catch on fire more easily, and it would successfully be able to make the steel wool catch on fire. The zinc nails had a negative charge while the copper pins had a positive charge, and the metal wire tied to the copper pins and zinc nails created a flow of electricity that would travel to the rubberized wires with exposed ends that would set the steel wool on fire. A single lemon with zinc and copper electrodes produces about 1 milliamp, about 0.7 volts, while an ordinary 9-volt battery usually produces about 500 milliamps in short bursts. So it's odd that it was able to catch on fire, but perhaps it had to do with the brand of the steel wool that I used. Perhaps it was a more flammable brand because the amount of electricity conducted by a lemon usually isn't enough to do something like that, but it happened. Lemon juice contains electrolytes which carry electricity itself, and it can't exactly produce electricity by itself, hence the amplification methods that I use for the experiment, but it can allow for 2 different metals to react with each other. And we call this a redox reaction, which is short for reduction oxidation. One metal gets reduced and gains electrons, while the other metal gets oxidized and loses electrons. These names, I know, can be a bit confusing because reduced makes it sound like metal is getting smaller, but it's not. And oxidized sounds like it is getting attacked by oxygen. But in the process, it actually doesn't acquire any oxygen. Oxygen does tend to oxidize metals, though, and metal oxides form when an oxygen atom steals electrons from the metal, forming a strong bond. Lemon juice contains citric acid because acids break up into charged anions and cations when dissolved in water. They conduct electricity because the charged particles are able to flow in the acid. Going back more to the experiments, the zinc nails have a negative charge while the copper pins have a positive charge. And the metal wire that was tied to the copper pins and zinc nails was able to create a flow of electricity that would travel to the rubberized wires with exposed ends that would set the steel wool on fire. So that's about it for this experiment and describing it. Thank you and stay tuned.